Hey, I'm John with Exceed. I am a solutions architect. I'm very excited to be bringing you a demo of our product and our MCP today. So, here is the home screen for our Terniion product. It's a simple dashboard, it's intuitive and easy to use. Our solution relies on agents that are installed on endpoints. They are highly configurable. And in this example today, I have some machines set up for Black Hat. So here are a couple of machines. Um, these machines have our agent installed on them. The agents are configured with bindings or a mapping. So the binding is for the local host or the client, and the mappings are for servers. This binding, you might notice this address is a loopback address, which is normally non-routable. And we'll touch on more of that later in the demo. Just wanted to do a quick call out to give you an idea of what we're working with today. So, I have my little environment here. It's a simulated industrial plant, just a few key endpoints. And I'm going to show off this same interface, but through an agent. And that's going to be using the MCP. The MCP doesn't replace the commander itself. The commander is designed for humans, and the MCP is for agents. So, I have a fresh session I just started. I'm using Hermes with GPT Soul. So let's start simple. Let's say I'm going to use voice to text, and I'm going to say, can you use the commander MCP to inspect the commander's health and then find the BH demo Black Hat ST links? And it's going to go off and do its thing. Okay, so you can see the commander is healthy. We have 138 ST links total, and here are the ST links associated with the demo. So it's really easy to retrieve and interact with your Terniion product using the MCP. You just state your intentions, and your agent will interpret that and do the rest for you. So let's move on a little bit, and we'll say I'm going to call out the field engineer. That's the employee with access to the PLC. So I don't know, let's say find the field engineer's Modbus route to the line 1 PLC and show its assignments. And while that's thinking, I can pop over here back into the engineer. You can see the binding right here. So again, non-routable IP address, and you can actually bind this to your DNS. So the employees don't have to use an IP address. You could say, PLC1 dot your fully qualified domain name, however you want to set it up. So it's easy for your employees to find it. Or maybe you already have some subdomains set up. You can just make sure the DNS points at this IP address, and the machine with the agent installed on it will resolve that endpoint through our product using an outbound only connection. All right, it found it. Here's that information. We have our field engineer here. Here's that binding that we saw in the commander. And yeah, so using this, it's outbound only connections. The field engineer actually doesn't even know the endpoint's IP address. So it's highly secure, allows you to completely close off your attack surface. You can close all inbound ports. We don't need any inbound ports on an endpoint at all, just an outbound 443. So it's pretty cool. The engineer doesn't need access to the LAN itself or any kind of general network access. Everything's done through the Terniion solution. So I just proved the commander, so we can see that from a conceptual standpoint, the connection exists, but we can actually have our agent test it. So I'm going to say, I want you to show the engineer endpoint proof. So please SSH into the engineer's machine and make sure the Modbus connection is actually working. So the agent's going to hop into the machine, and it will actually return a real proof of the data plane functioning as intended. Okay, so I just had the agent SSH into the host itself. It's running in a virtual machine. The binding is there. Status okay. Yep. Route found. Sees where it's listening. And then, yes. Okay. So this is the request it sent to the Modbus, and it got a successful exit code. So the script and the connection worked. So this is an engineer working internally that has access to your assets. But let's extrapolate a little bit more. Let's say you have a contractor. The contractor is coming on site, needs some access to some equipment, but you're security conscious and you don't want to go through the effort of giving him explicit access in your complex environment because there's a lot of sensitive stuff. You can use some software like Kasm here to run a containerized load. So these loads are meant to be ephemeral. And what I've done is I've created an Exceed private application that attaches to a Chrome browser, our agent to a Chrome browser. And this agent allows you to dish out access only through the ephemeral application running in a containerized environment. So you don't have to worry about giving any network access at all or installing an agent on a contractor's machine. So let's go to our HMI. Let's say the engineer contractor needs HMI access. So here in this application, this is the binding, the same non-routable IP address. It's only available inside of the container. So for example, let's say I try and put this in on my Mac. It's not going to resolve. We can come back to the screen, but I can tell you it's not going to resolve because I don't have the binding on my host. The binding is only inside of the container, which is running this browser. So here's the human machine interface. We have a pump valve, alarm acknowledgement in the alarm itself, and a little tank. And this is all running inside of a PLC on a virtual machine. And the HMI is the only agent or application authorized to communicate with that PLC. So I can turn on the pump and the pump will begin filling. I can open up a valve to let more flow occur. And then once it reaches 100%, you have an alarm, tank is full. So I can acknowledge the alarm, turn off the pump, and the pressure will begin to drop. So nice little demo I created. And then once the engineer has done what he needs to do inside of your environment, he can just close the application. Yep, leave. So just to recap, this browser is running inside an authorized Kasm workspace. A Terniion companion provides that workspace with a separate local binding to the plant. So the engineer never had access to the direct access to the network. Everything was done in the most secure manner possible. Great. Now let's take a look over here. Yep. Couldn't resolve as intended. So we started with the manage assets in the commander right here. The AI agent then uses the commander's MCP interface to discover those assets and inspect the exact bindings an engineer or any employee might have access to, or it could be server-to-server access. This is, again, highly, highly configurable. We proved real Modbus traffic from a field engineer to a PLC, demonstrated HMI access from an authorized Kasm workspace, and confirmed that same private resource remained unavailable outside of that endpoint. So the agent operated through the commander's control plane. The engineer received access to those resources, not a route to the plant network. And that's it. Thank you for watching my demo. Come talk to me at Black Hat.